Okay, here in our section 1-2, Additive Inverses, we actually discussed this a week ago in our very first lesson, but I want to show you some more complex examples, if I could say it, and I want to show you how it's still so incredibly easy. So what is an additive inverse? Well, it's essentially just if something is positive, we make it negative. If something is negative, we make it positive. And the reason we do this is because our additive inverses, a positive plus a negative of the same quantity, will always add up to be 0. So our additive inverses create a 0 pair. Okay, so for example, if I said, what is the additive inverse of positive 10, you would say negative 10. If I said, what is the additive inverse of negative 3x, you would say positive 3x. And that's literally all you do. You just change the sign. And these things, because they're inverses, they get rid of each other. Negative 3x plus 3x, if we were to add them, would equal 0. Okay, example 3. What is the additive inverse of negative 3/8 x squared? All you do is change the negative to a positive. And so we'd have 3 positive 3/8 x squared. Now I would encourage you to pause the video right now and write down what you think the additive inverse of example 4, 5, 6, and 7 are. Just pause it. Try it out. You can even pause it and just say it. Alright, well, what are they? Well, positive 2 over y cubed, the additive inverse, is negative 2 over y cubed. Okay, here we have a positive 6z to the 10th power, so the additive inverse would be negative 6z to the 10th power. Down here we have negative 0.12d to the 8th power. The additive inverse would just get rid of that negative. It would be positive 0.12d to the 8th power. How about here, example 7? This might be the most complicated looking thing we've seen so far. What is the additive inverse of positive 15 xy cubed over 7z squared? It's literally the same thing. We just put a negative out front. Negative 15 xy cubed over 7z squared. And remember, whenever you have a fraction, the negative or the positive is essentially talking about the entire fraction. And so don't think that if both the top and bottom are positive, that the additive inverse, that both the top and bottom are negative. That wouldn't really make sense, because a negative divided by a negative is still a positive. So just change the sign of the entire fraction, not each piece individually. Alright, I hope this helps, and I'll see you guys in, well, you know what, I'm sorry. We have actually 2 more examples to cover. 2 more. So, that was example 7. Well, here's going to be our example 8. My apologies for getting your hopes up. But, here we have this. X plus, let's say 10a cubed is equal to 10a cubed minus 8. And what if I were to say, hey, I want you to solve for x? Well, you would want to get x by itself, which means you would want to get rid of the positive 10a cubed. So, what is the additive inverse of positive 10a cubed? Well, that would be negative 10a cubed. And remember, whatever we do to the left side of the equation, we have to do to the right. So, this would cancel out. It'd be a 0 pair. This would cancel out. It'd be a 0 pair. And we would say x is equal to negative 8. So this is why additive inverses are so useful. They can really clear up a function or an equation for us very quickly. Okay, let's do one last one. Here's our example 9. And let's say something a little crazier. Let's say negative 3d to the 8th minus 4x is equal to negative 3d to the 8th plus 12. Once again, I'm asking you to solve for x. So how would you get rid of a negative 3d to the 8th? Well, the additive inverse would be plus 3d to the 8th. And remember, what we do to one side of the equal sign, well, of course, we're going to have to do to the other. And now, this becomes a 0 pair, this becomes a 0 pair, and we're left with negative 4 x, sorry, I'm having some difficulties writing here, is equal to 12. Okay, now from here, notice x is not by itself. How do we get rid of that negative 4? Well, of course, y'all are pros at this by this point. You know we just divide both sides by negative 4. And 12 divided by negative 4 would, of course, give us negative 3. If you have any difficulties with the calculations, I have included a calculator up at the top, and I'll see y'all in our next section. For real this time, I actually mean it.